Hello students, let's see the MCQs based on hybridization and geometry of the molecules. Before going into the MCQs, let us take a glance on how to calculate the type of hybridization and number of lone pairs in the given molecule. So let us take a simple example, that is methane. Here you have to first select the central atom. Here carbon is the central atom and you have to consider the number of valence electrons on that central atom. So here it will be 4. Plus you have to add the number of monovalent atoms or species which are attached to the central atom. Here they are 4. Make a total, it comes out to 8. Divide that by 2, you get 4. Now students, you know the orientations. For S there is one orientation, for P there are 3 and for D there are 5. So now you have to adjust this 4 number according to this. So for 4 I will have 1 S and 3 P's. So the hybridization on carbon in methane, it will be sp3 hybridization. Now to calculate the number of lone pairs, this number what you got, you have to find the difference between this number and the total number of connecting atoms to that central atom. So here it is 0 lone pair. So carbon in methane will have sp3 hybridization with 0 lone pair. So by using this trick, we'll be solving the remaining questions. So let us come to question number 19. Which of the following is the correct set with respect to molecule, hybridization and shape? So let us try one by one. The first example is BeCl2. Beryllium, the number of valence electrons on beryllium are 2. Plus the number of connecting monovalent are 2. Total comes out to 4. Divide this by 2. You get 2 and therefore this will undergo sp hybridization. And if you see the difference here, the difference is 0. So there is no lone pair here. So the geometry will be regular. So what is the geometry for sp hybridization? Is linear, but here they have given sp2. So the first option is wrong. Here also this BeCl2, this sp2 hybridization is wrong. So the first two options, they are wrong. Let us check for the third one. Third is BeCl3. So let us calculate for BeCl3. BeCl3, boron is the central atom. So it will have 3 electrons in its valence shell plus 3 connecting monovalent. Total will come to 6. Divide 8 by 2. You get 3 and therefore it will undergo sp2 hybridization. If you check the difference with 0 lone pair, means it will have a regular geometry of triangular planar. So if you see the third option student, the answer here is third option. If you check for fourth, here they have given sp3, so this option is wrong. So the correct option for this question is option C. Come to the next one. Pi bonds can be formed between, you know students, carbon to carbon double bond and carbon to carbon triple bond you have seen in alkane, alkene and alkynes. Therefore carbon is capable of forming pi bonds. Oxygen forms a double bond between two oxygen atoms and therefore it is also capable of forming a pi bond, and same with nitrogen, it can form a triple bond between two nitrogen atoms. So even nitrogen is capable of forming pi bond. So answer here is all of these. See the next question. Which does not have sp hybridized central atom? Means which among the following will not undergo sp hybridization? So let us see the first molecule, XeF2. Xenon is from 18th group, so it will have 8 electrons in its valence shell. Connecting monovalent 2, total comes out to be 10. Divide this by 2, means you get 5. Means which type of hybridization? sp3 dehybridization. So you see here there is no sp hybridization. Similarly, let us take for, you can check for the remaining 3, that is C2H2. You know here carbon undergoes sp hybridization. In carbon dioxide also it will undergo sp hybridization, and BeH2 also it will undergo sp hybridization. So which does not have sp hybridized central atom is XeF2, and answer is first option. The species in which the central atom uses sp2 hybrid orbital in its bonding. So you have to check that which among the following will undergo sp2 hybridization. So let us check this. The first example is PH3. Phosphorus is from 15th group. So the number of valence electrons will be 5. Connecting monovalent is 3. Total comes out to 8. Divide this by 2. That will give you 4. Means it will undergo sp3 hybridization. Second is ammonia. Nitrogen is from 15th group. It will have 5 valence electrons plus connecting monovalent 3. Total will come to 8. Divide that by 2. You will get 4. So it will undergo sp3 hybridization. Next is CH3 plus. Carbon is from 14th group. Valence electrons 4 plus connecting monovalent 3 minus the positive charge. So this total will come out to be 6. Divided by 2, so it will give you 3 and it will undergo sp2 hybridization. Let us check for the last one, SbH3. Antimony is from 15th group, so valence electrons will be 5 plus connecting monovalent 3. Total will come to 8. Divide this by 2, you get 4, means it will undergo sp3 hybridization. So this all three they are undergoing sp3 hybridization except this. So in CH3 plus carbon will undergo sp2 hybridization. So answer here is third option. See the next one. The molecule which has pyramidal shape is, if it is showing pyramidal shape means it will undergo sp3 hybridization with one lone pair. So I have to check the molecule that will undergo sp3 hybridization with one lone pair. So let us go for the options what are given. The first is PCl3. Phosphorus is again from 15th group, valence electrons 5 plus monovalent 3, total comes out to 8, divide this by 2, you get 4. So it will undergo sp3 hybridization and the lone pairs here will be one lone pair. So students, this is the option, but let us check the remaining options also. In case of SO3, sulfur is from 16th group, so valence electron 6. As this is not a monovalent species, so I will not add anything. Total will come to 6. Divide this by 2, you get 3. So the hybridization here will be sp2 with no lone pairs. So this is 0 lone pair. See the next one, that is CO3 2 bidas. Carbon is from 14th group, so there will be 4 valence electron plus this is not monovalent, but now there is a charge, so I will add that negative charge. Total comes out to 6. Divide by 2, it will be 3. Again it will undergo sp2 hybridization with 0 lone pairs. Check for the last option, that is LO3 minus. Nitrogen is from 15th group, valence electrons 5 plus this is not monovalent plus negative charge. Total comes out to 6 by 2, 3 sp2 with 0 lone pairs. So students, which among the following will have pyramidal geometry is PCl3 because it undergoes sp3 hybridization with one lone pair. Means the geometry will be like ammonia. So answer here is the first option, that is PCl3. Come to the next one. The type of hybrid orbitals used by the chlorine atom in ClO2 is, if I see the ClO2 molecule, you can do this simultaneously with me students. ClO2 minus. Chlorine is from 17th group, so it will have 7 electrons in its valence shell, plus this is divalent, so I will not add this, plus the negative charge. So total comes out to 8. Divide this by 2, you get 4, means it will undergo sp3 hybridization. Check for the lone pairs. So there will be 2 lone pairs on this particular atom, and therefore which type of hybridization it will undergo? sp3 hybridization. Geometry will be like water, that is bent. Let us see question number 25. In question number 25, the following species what they have given, you have to identify the isostructural pair among the following. Students, if they are isostructural means the type of hybridization the central atom will undergo must be same. So first let us write down all the molecules what they have given and let us practice or try the type of hybridizations along with lone pair on each and every molecule. So let us first write down all the molecules. Now let us try one by one. Here nitrogen is the central atom. It is from 15th group, so it will give 5 electrons from its valence shell plus connecting monovalent 3. Total comes out to be 8. Divide this by 2, it comes out to 4. So it will undergo sp3 hybridization. If you see the difference here, it will have one lone pair. Check for this. Nitrogen again 5 plus 0 because this is divalent. I will add the charge 1. Total will come to 6. Divide this by 2, I will get 3. Means it will undergo sp2 hybridization. If I check the difference here, there are 0 lone pairs. See this, This will have 3 valence electrons plus connecting 3. Total will come to 6. Divide this by 2, you get 3. So it will undergo sp2 hybridization. If you check the difference here, it is 0. So 0 lone pair. Come to hydronium ion. Oxygen is the central atom plus connecting 3 hydrogen minus the charge which is there. So the total will come to 8. Divide this by 2, you will get 4. So it will undergo sp3 hybridization. Check for the lone pairs. So there is 1 lone pair here. So this is what you will have for hydronium. Now students, this particular molecule, that is HN3, this is hydrogen azide or hydrozoic acid, and the structure for this is something like this: nitrogen, double bond, nitrogen, double bond, nitrogen, single bond, hydrogen with the lone pairs here. Now here the hybridization here will be calculated for this atom. So nitrogen will give you 5 valence electron plus connecting monovalent 1 hydrogen is there. I will not take this as the neighboring atom because it is not monovalent. So total will come to 6. Divide this by 2, it will give you 3, and therefore it will undergo sp2 hybridization. If you check for this lone pairs, this is the first connecting, this is the second connecting, here it is 2. So it will have 1 lone pair. Now students, let us find the pairs that will have the same structure. So if you check, this is sp3 with 1 lone pair, and this is also sp3 with 1 lone pair. So the first pair what I will have is NF3 and H3O plus. So NF3 and H3O plus I have in the third and the fourth option. So I need to check out this also. So let us see where we have other options, that is this NO3 minus, that is sp2 with 0 lone pairs, and BF3, that is sp2 with 0 lone pair. So the second pair will be nitrate and BF3. So here your answer is third option. Let us see the next question. Geometry of the molecule is distorted according to VSEPR theory for. Now students, if the molecule is having distorted geometry, means there must be the presence of lone pairs. So you have to first find out the type of hybridization and number of lone pairs in each molecule. So let us try for the one. The first they have given is water. The second is NH3, N3H and XeF2. Those are the molecules. So let us check for H2O. Oxygen is the central atom. It will contribute 6 valence electrons plus connecting 2. Total will come to 8. Divide this by 2. You will get 4. Now if you check here, this will have sp3 hybridization and 2 lone pairs. Check for this, 5 plus 3. Total will come to 8. Divide this by 2. Again 4. Again it will be sp3 hybridization, but there will be 1 lone pair. See the third one. Hydrazine structure like we have seen. Nitrogen, double bond nitrogen, double bond nitrogen, H. Right. So if I check for this, it will give 5 electrons plus connecting monovalent 1. So it will give you 6 divided by 2. So this will give you 3. It will be sp2 hybridized. Let us check for the number of lone pairs. This is 1 connecting. This is second connecting. So there are only 2 connecting atoms. Here it is 3. So difference of 1. So there will be 1 lone pair. Come to this. Xenon is from 18th group because xenon is an inert gas. So it will contribute 8 valence electrons plus connecting monovalent 2. So total comes out to 10 divided by 2 will come to 5, means it will undergo sp3 and D hybridization. So let us check the number of lone pairs. Connecting is only 2 and here you got 5. Therefore there are 3 lone pairs here. So in all the molecules which are given, there are lone pairs and therefore geometry will be distorted, and so the answer is third option. First, second, third, fourth, they all have lone pairs and so they will have distorted geometry. So answer here is third option. See the next one. Here some molecules are given in list A and you have to match them to list B with the proper shapes. So let us write the molecules first. So the molecules they have given, they are PCl5, F2O, BCl3 and NH3 in the question. Now let us see the geometry one by one. So let us first calculate the type of hybridizations. Phosphorus here will contribute 5 valence electrons because phosphorus is from 15th group, plus connecting monovalent 5, total will come to 10. Divide this by 2, it will give you 5. So the hybridization will be sp3d. The regular geometry for this is to calculate the geometry, student, if you get this number 5, subtract 2 from it. So you get a triangle. 3 means the proper geometry will be a triangle, and the 2 what you have subtracted, 1 up, 1 down. Let us check the lone pairs. Here there are no lone pairs. So the geometry will be trigonal bipyramidal. Trigonal bipyramidal. So this is the first one. Come to this F2O. Oxygen is the central atom. So it will contribute 6 electrons. Fluorine, so I will add 2. Total comes out to 8. Divide this by 2. You get 4. How many lone pairs will be there? Plus 2 lone pairs. sp3 hybridization will be there. So regular will be tetrahedral. But because of the 2 lone pairs, the geometry will become bent or V shape. Come to the next one, BCl3. It will contribute 3, monovalent 3. So total will come to 6. Divide this by 2. You will get 3. So it will undergo sp2 hybridization. There won't be any lone pair. So the geometry will be your regular triangular planar. So the geometry will be like this. See the last molecule, NH3. 5 electrons from valence shell of nitrogen plus 3 hydrogen monovalent, it will come to 8. Divide this by 2, you get 4. So hybridization will be sp3. There will be 1 lone pair, and so the geometry will be distorted tetrahedral, or you can say trigonal pyramidal. So according to the options what are given, let us check. They have given the first is PCl5. So students, the first molecule is PCl5. For PCl5, we have find out the geometry as trigonal bipyramidal. So here it is given in the third option. So first A will be third. So answer here, if you check, it will come to fourth option. Come to the next one. So this is the chart for F2O. It is V-shaped. So that is F2O, that is second. That is B, it is showing V-shaped, and then for C, it is triangular planar. So this way the geometries will be matched. So the answer here is fourth option. See the next one. T type of shape is exhibited by the molecule. Students, if it is showing T shape, means it will undergo sp3d hybridization with 2 lone pairs. So let us check one by one. The first molecule they have given is ICl3. So that is iodine is from 17th group. So it will have 7 electrons in the valence shell plus connecting monovalent 3. It will come to 10. Divided by 2 will come to 5. Plus it will show sp3d hybridization. Regular geometry will be trigonal bipyramidal. So for that, let us check the number of lone pairs. So there are 2 lone pairs. So the geometry will be this. In this way, 1 up, 1 down, and the 2 lone pairs will be located at the axial positions. So the shape of the geometry will be this, that is T shape. So T shape geometry will be seen in ICl3. So answer is first option. The pair of species with similar shape is, if they have similar shape, they must have same type of hybridization. So let us see the first one. PCl5, phosphorus is the central atom. It will contribute 5 electrons plus connecting 3. Total is 8. Divide this by 2. You will get 4. Means it is undergoing sp3 hybridization. See the NH3 molecule. In NH3, it will be 5 plus 3, that is 8 by 2, 4. Again it will give you sp3 hybridization. So here the answer will be first option. Let us check for the remaining options also, students. Carbon, that is CF4 and SF4. Carbon will contribute 4 plus connecting monovalent 4. Total will come to 8. Divided by 2 will give you 4. sp3 hybridization. This is from 16th group. So it will give 6 plus monovalent 4. It will give you 10. Divided by 2 means it will give you 5. So sp3d. So both are not matching. Similarly, you can go for PbCl2 and CO2. Pb, that is lead, is from 14th group, so you can have 4 plus 2, 6 divided by 2 will give you 3, and so this will undergo sp2 hybridization while CO2 will undergo sp hybridization. Here PF5, 5 plus 5 will give you 10, divided by 2 it will give 5, so here phosphorus will undergo sp3 dehybridization while this will undergo 7 plus 5, 12, divided by 2 will give you 6, so it will undergo sp3 d2 hybridization, and therefore the species with similar shape, means similar hybridization, will be seen in first option, that is sp3 and sp3. Students, I hope you have understood the concept how to find the hybridization on the central atom by this shortcut method. You can practice few more questions related to this, and I hope you like this video. If you find this useful, please do share with your friends. Thank you for watching.